So welcome everyone. Welcome to the session Implementing Zero Downtime Application Deployments on Azure PaaS. And when I woke up this morning, I got all kinds of messages from some of my colleagues that said to me, Marcel, you're doing a session on zero downtime, but are you aware of the fact that your cloud provider is actually not? I added the subtitle for today, assuming your cloud provider is up and running, because apparently this morning they had an outage of about 4 hours on networking. I am assuming that our cloud infrastructure is there. And on top of that, we will try to do zero downtime deployments of our applications using different PaaS services that we can use within Azure. My name is Marcel de Vries. I'm the CEO of Xebia Spirit, and CEO stands, in my opinion, for Coding Executive Officer. I strongly believe in the ABCs of always be coding, because I think that's the best way to work with your tech teams to actually bring quality applications to your customers. So let me get started with first, what are the ingredients to be successful if it comes to doing a zero downtime deployment? And for that, we need a couple of ingredients. And in my hobby time, I'm also a hobby cook and a hobby chef. So I thought, why not use just like ingredients that we need? So first of all, we need a stateless application. And apparently, although this is something that we've been striving for, I think since the 1990s or something, that is a good way to scale your applications, I want to have just a short conversation on what means stateless and what can we do with that state. Then the next thing that we need is we need to separate what we call deployment from release. And apparently, in all the years that we've been doing IT, this is not very common for everyone. And what I mean by separating deployment from release is something that we will go into more detail, but it has to do with the fact that we want to get rid of the fact that the moment we install software on a server, that does not mean any downtime, right? So we need to figure out a way to do it in such a way that we can deploy while our application is up and running. And that's the reason we need to split deployment from release. The other thing that's crucial in terms of being zero down is that you need to add observability to your application. And I will go in a little bit more detail there. I have a nice and little demo also to show you what you can do if you're working in, for example, the .NET ecosystem to get observability into your system. And I will have a short chat with you on what does it mean in terms of observability in relation with these PaaS services that also rely on some information they need to ensure that they can either roll forward or roll back your deployments. The other thing that I need to discuss is infrastructure. We need infrastructure to make this happen, so we'll have a look at specifically two types of infrastructure. I would say mainly two types of infrastructure within Azure, and that is Azure Web Apps and that is AKS, Azure Kubernetes Services, because those are the two most popular parts of the platform. And then I will end with a conversation on, great, so now we're doing these zero downtime deployments, but Marcel, nobody ever talks about, I also have a database schema change. So let's have a conversation on that and how do we make that happen? Because that is something special and it needs to be treated with care. And you also need to know what to automate and what not to automate, because that's also important. Some things just are not, I would say, economically feasible to automate and perhaps give you even more control while not automating. So it's not always automate everything, just be very specific on what you automate. So let's have a short conversation on stateless. Because when we talk about stateless applications, what is it that we mean? Well, what we mean is that the moment we get in a request, I can still build up some state if it comes to processing that request. Nothing to worry about that, because the idea is that we are stateless between different requests that we have. Okay? So meaning stateless has the meaning of, okay, I can accumulate state during the processing of my request. For example, the outcomes of calculations, the information you retrieve somewhere and made some decisions based on that. But then the moment we start giving the reply, we need to ensure that we then get rid of that state in one shape, way, or form. And we either need to choose then to store that in a state store behind your application, meaning a database, a Redis cache, a local disk, some kind of storage, or you wrap it up and then give it back to the client so that the next time you get in a request, you can pass it along the state that you accumulated so that the service itself or the API itself is not bothered with the fact that it needs to get the state from somewhere. And it cannot be in memory. That's something that is not possible because what we're going to do is we're going to shoot our application through the head while we're in production, okay? And then we need to make sure that that state is somewhere, either in some backend storage or you package in something that you give to the client and then stuff it in a cookie or just push it in the reply and know that you need to pass it along the moment you do the next request. Now, if you look at separating deployment from release, what we've been used to do, and that's been common practice, and I still see it happening. I'm not sure if that's the same here in the UK, but last Friday I wanted to do something in my bank account, and then all of a sudden it goes, sorry, but we are not available. We are doing an upgrade of our application. And go, wow, it is 2023 and we still have downtime. Why? Well, what happens is that people then did not separate release from deployment. Because what they do is then say, okay, first we need to stop the traffic to my application, hence the sign, sorry, you cannot get in. So it's more like, okay, we set this thing in front of our application and then we ensure that no traffic comes in anymore. Then we just uninstall our application. Next, we reinstall version 2 and then we remove the barrier and we are back online again. And we need to figure out a way to separate these two concerns of doing the actual deployment versus the traffic that we get in and then redirecting that in some way, shape, or form. So what we need to do is we need to get started with something that understands the routing of your traffic. So that is the foundational piece that you need to do a zero downtime deployment. You need to have something that is aware of the fact that something came in as a request and that the reply was sent. We cannot terminate anything that is in flight. We can terminate everything that is not either sent or after it's been returned, okay? So what we are going to do is we're going to install version 2 on some separate piece of hardware, some separate piece of infrastructure that we have. And then what we will do is we'll say, okay, let's move the traffic to version 2 of my application. Then the next step is, of course, we stop the traffic of application number 1, and then we uninstall the application. Rather simple, right? It's not that difficult. Well, there are some, of course, challenges that you need to be aware of. Now, of course, we can go further with it. We say, well, we now install version 3, and then we move the traffic to 3, and then we stop the traffic on the other one, and we can go back and forth and back and forth. This is better known also as blue-green deployments. Perhaps you have heard of those. This is a very common practice, and this got started when we did web applications back in the, 90s and the 2000s, or the zeros, I should say, right? Where we built the first web application, we did the traffic routing. And we had on, for example, IIS, the whole notion of application request routing and those kind of things to get your traffic to another instance of the application on the server. Now what we need is we need some way to route our traffic. And for this, in Azure, you can use something which is called Traffic Manager. So Traffic Manager is, by the way, something that is not really, I would say, an active load balancer or something. But Traffic Manager is more or less some trickery that they are doing with DNS. So what's actually going on is somewhere on the DNS servers, you ensure that it knows where the endpoints are, and it will then ensure that the moment we have some unavailability of our application, the traffic is routed to the other IP addresses underneath. So Traffic Manager provides 4 options that we have. It can route traffic based on availability. So is my service up and running? It provides routing based on round robin, giving you a little bit of load balancing across different servers that you might have. It can do traffic-based routing on weight, and that means that you can give percentages. So you can say, okay, let's move 10% of my traffic to one server and 90% to the initial server. And you can also do traffic routing based on latency, which is of course more interesting if it comes to, okay, we have people in Australia, people in Europe, and people in the United States. You have 3 server farms and you want people to connect to the most local instance of your application. Now, in the context of zero downtime deployments, we are interested in option 1, the availability of a service, and we're interested in option 3, we want to move traffic based on a certain weight, because when you install a new application, do you want to hammer it all of a sudden with like 100% of traffic, or would you like to slowly turn on the knob if it comes to that traffic? Now, Azure also has the notions of web applications, and web applications have a capability called a deployment slot. Now, a deployment slot is nothing more than, I would say, a second instance of your server. Be careful, it's on the same application service plan, meaning that if you're hammering the server on the one hand, your application or your server is being used. So don't start doing load tests all of a sudden on a second instance that you create or a second slot that you have. But the idea is that it can then help you swap between those different environments. So you create more or less a copy of what you have. You can then install the new software on there and then do a so-called VIP swap, which is then the virtual IP swap, meaning that the traffic will go to the other way. Now, this is something that we want to use because this will really help us do the installation, move the traffic, and then swap around, like I just showed you in the picture. The other thing is that if you do the red-green deployments, it also really helps you in terms of easy rollback. Now, to be honest, I have the opinion that rollbacks is for chickens, because I think you should roll forward as long as you have enough automation and performance in your deployment pipeline. But that said, you can roll back because you can just ensure, say, okay, it's not going that well with my application, just move to the previous instance because that one was running okay, because it's still there and it's still up and running. It becomes a little bit more difficult if you do the schema change, but we'll come to that later. Now, if you look at Azure App Services and the App Service plans and then slots, what we can do is we can do traffic routing based on these deployment slots. So we can set a percentage of traffic that needs to go to one of these slots, and you can have up to 20 of these different slots. So you can even have 20 different versions of your application in production and have like 2% to this and 5% to that and 10% to that, and then eventually will add up to 100% of your traffic. And it will then ensure that the traffic will go to one particular server. What happens underneath the covers, and I will show you that in a few minutes, is that this is cookie-based, meaning that the moment you go to one instance or one slot, that means that you will get a cookie, and based on that, the application request routing underneath will pick up the cookie and know, oh, you need to go to that server. Okay? So that way you are ensure that you will go to the same version of the application, because you can have multiple versions of your application in production. And it might be strange, perhaps, if you are going to V1, V2, V3 all the time, back and forth, while you're doing just one transaction with your application. Now, what is also nice is that there's this option that you can add a question mark to your URI, and this will then instruct the routing infrastructure to go to a certain slot. And this is interesting when you have, for example, groups of users, often called a cohort of users, that you selected to validate certain new features. Because then you can send them the email, and by the way, we have version 2 there. Nobody will go to version 2 except when they have this thing in the header, or in the URI, and that, well, everybody clicks emails, right? So that you just send it in the email and they will click it. And after that, they have a cookie, and they will go to that particular version. Now, the moment you would take out that version or that slot, it will just revert to production, so that it will then get rid of that instance of that version. Make sense? Okay, good. Let me show you web apps in action just very shortly. So what I did is I created the NDC web app, and you can see over here that this web app is found over here, and this is my Globo ticket application. You see, this is the most fancy application to buy tickets, and I made it extremely ugly so that you can see different versions of my ugly application, okay? But then at least it's visible what we're doing all the time. Now this application goes to a backend store, retrieves the ticket information, and then you can buy tickets. It's your, I would say, average run-of-the-mill type of application where we do demos with, right? There's nobody runs this in production, only we on stage. Now, this application is deployed to, you can see that this is my production slot because there's nothing special about this URI except that's just the name of this application. But I can go over here and go to my deployment slots. And you can see that I have 2 deployment slots here. You can see that I have a deployment slot called production. And you see that I have the NDC web app staging. That's the one that I created. And I can create multiple of these. And you can also see that there is traffic percentage over here. So I can state the percentage of traffic I would like to route into a particular instance of a slot that I have. Now be very careful here, because you want to use this question mark thing on the URI. The moment you create these deployment slots, you will see the exact same picture as this, but this is then a little bit grayed out and 0. That means that even if you send in the question mark whatever, it will not route there because you not allowed it. What you need to do is, very obvious, you need to punch in the number 0, press save. You have exactly the same result, a little bit less vague than the gray. And then that's the moment you can go to that particular slot. You enabled or more or less made explicit that you can route traffic there. It's in the documentation, but I just want to mention you because when you do this the first time at home, you go like, what's going on? And of course, this always takes me some time to remember, like, oh darn, yeah, I had to do the 0 in there. So if I go to staging, you will see that I see the exact same view within Azure if it comes to my application. But the big difference here is when Azure is up and running, it should show me here another URI. And that other URI shows me then where my URI is if I would like to go to staging. Luckily, I know where that is, so I can go here and then say, let's go to, it's just a naming convention, dash, and then staging. I need to type that without caps, staging. I don't want to shout on stage, right? So staging, enter this. Oh yeah, I deleted the P, thank you. That's why I love an audience that helps me. So now you see it's more ugly, but now it's blue, okay? So you see that I have 2 different versions here. I can now go back and forth. Now what's interesting here is that I can also go again back to this location over here. You see the orange one. And now I can do the question mark routing staging. Then I need to do control click because otherwise it's not refreshing my CSS thing. But you see that now it picks up the blue one. Now what I find intriguing is that it now set a cookie. So from now on, I will go here all the time. Okay, so this is the way you can pin somebody to a specific instance, but the moment this one becomes unavailable, it will route it back because that's the traffic routing behind the scenes that knows, oh, it's not available anymore. Let's route it back to the initial instance. So this is what you can use for zero downtime deployments, at least splitting the deployment and actually the release of your software. And we will take that a few steps further in just a couple of minutes. One thing I can show you, by the way, is here are the settings. If I go to all my cookie data and go to NDC, you will see that I have my websites.net. If I go here, you can then see that I have the ARR affinity. For those that have also worked in the 90s, this is still application routing cookies that are used based on the good old IIS infrastructure that was there in the past. Yeah, those are the cookies that you have, and then there's not much that you can see, but they are at least here. And if I remove them, then we'll go back to the original instance. So that's web apps. Web apps are really handy, easy to use. Just deploy a new application, move there, and you're done. Okay. Now then there's this infrastructure that everybody loves and hates, I think. If I go to conferences, then there's a lot of talks about Kubernetes. And the fun thing is that Kubernetes has a lot of this stuff that I just showed you more or less inside of the box. It's just part of the infrastructure that you roll out when you're doing Kubernetes. Now, of course, it's container-based. It has this notion of health endpoints, which we'll come to, and it can do the traffic routing for me. And for that, I want to take you on a little bit of a journey on what that implies within Kubernetes so that you understand what's going on behind the scenes the moment you're using this stuff, okay? So just a few concepts just to get you refreshed on Kubernetes. So who's using Kubernetes today? A few I see, okay. So let me give you a refresher and hopefully, it's interesting for everyone. But the idea is that we do deployments and we do a deployment, and a deployment implies that we have a set of what we call pods. A pod can contain one container or more containers, and those containers together share the same IP range in the same port range that you have. So you can address it on the exact same IP address with the exact same ports, and it will go to those containers. It also shares storage. And well-known patterns there, people might have used that, is the notion of sidecars. So the idea of a sidecar is, for example, that you have a container in here that does some network magic. And then for that, it can, for example, do SSL traffic while you are not aware of the fact that you're doing SSL traffic. This is what happens when you're using service meshes, for example. They have a sidecar that will take care of the certificate exchange and the SSL implementation, while you can just roll out your application without any taking care of anything of that security thing. Okay? So this is what we call a pod. So a pod contains one or more containers, and we can route traffic to that particular pod. Now, if we would like to, let's say, host a web application, I could say, well, give me just one container in one pod, and I can route traffic to there. But the idea is that we more or less use different types of nodes that we have in our compute cluster that we can then distribute traffic amongst. And what we can do is we can say, well, this application needs to be up and running a little bit more than usual, so I can up my replica count, meaning that I want more pods of the same type, but then distributed across my cluster on different nodes. I can even say I want it on different nodes. I can say, well, I want it on a specific node set that we had, or a node pool, because that has, for example, GPU capabilities, and the other is more like memory optimized, or the other is compute optimized. You can have different node pools where you can move stuff to. Now, the replica set is responsible of creating enough instances of those pods based on a definition that we created. And the definition is what we call the desired state. So what we do with the Kubernetes clusters, we say, hey, cluster, can you give me 3 instances of my web application, and it will go and fix that for you. Now, those 3 instances will then be replicated across the different nodes, making sure that it lands on the right compute that you want it to be. Now, what it will also do is it will take care of looking at how well is my application doing. It has this notion of what we call liveliness probes. It can check is my application still up and running, yes or no? How healthy is my application, which we call health endpoints. It can also probe a so-called readiness endpoint, and we'll get back to in that a little bit more detail, because a readiness probe tells me that I, as an application, am ready to receive traffic. Now, you might see where I'm going here, because I can then indicate that I'm ready to receive traffic, meaning that the moment my application comes up, it can then do some munging, perhaps fill some caches, reach out to queues, get some connectivity to other systems, and then signal, I'm ready to be used. That ensures that initial requests coming into your application are pre-cached, are ensured that it will be responsive, instead of your first call all of a sudden being hit and waiting like for seconds for something to happen. So that readiness probe is really important, because it is used to determine if traffic can be sent to your instance of your application. Okay? If you do not provide this, it will just send traffic the moment the thing comes up. Okay? So that's important to know. Now, furthermore, Kubernetes has, in the desired state configuration, a definition of, am I doing a so-called rolling update, or do I replace? Now, when I do a replace, it is compared to what I showed you before. We just put the marker in front, no traffic allowed. You replace your application, it comes up again, and then we get traffic again. Okay. Now, if we do a rolling update, it will take care of bringing new instances into into the cluster, ensuring that we can send traffic there, and after that, deleting or removing the old pods and then removing the traffic from those particular instances. Now, this implies that you see that pods are mortal, meaning we can spin them up, we can spin them down, but they have a particular IP address. So I need to take care in some way of the networking infrastructure to ensure that I'm routing to a certain place so that I'm not all of a sudden confused like, oh, the pod is gone. Okay? Because it might have been shot through the head or might have been recycled because my liveliness probe might have said, I don't feel so healthy anymore, shoot me through the head, give me a new instance, okay? And I will show you in a few minutes that you can program these liveliness probes yourself, for example, on your memory consumption or other stuff that you think, okay, this is not healthy, give me a new fresh instance, for example. Now, by the way, this is not a way to mitigate memory leaks, you just need to fix them, but it's the cheap way to get yourself into an okay-ish state. Now, this desired state needs to be defined in YAML. Okay, so what we will have is we have what we call the deployment, the replica set, and the pod. And we have one or more pods that we have in a deployment. Now, what we do is we define then that we do a deployment. We specify the number of replicas. So I'm saying I just want one pod of this particular application. Then I'm going to define the container comes from some location, which is then called the container registry. And I'm just, in this particular case, saying, well, I want to have global ticket web, which is then the front end, and 433 is then the port number that I'm interested, or sorry, the tag name that I'm interested in. Now, of course, I can specify additional configuration information, and this is then what gets up and running. Okay? Yeah. So, now, what is important is that you know that we have these pods running in our cluster. And all these pods are here, but I need to find a way to route my traffic to specific instances of those applications that we have. So for that, we use labels. So we set a label, for example, this is the backend. And I'm interested in this, and then I can define something which is called a service. So I can say, give me a service, pick up any pod that has the label backend, and then it will take care of the routing of the traffic to those particular pods. It will then, on its side, give you one IP address that you can go to, and that IP address is stable. This is also available by name in terms of DNS within your cluster. Okay, so if you would go to a service based on its name, it will always resolve to this particular IP address, and it will then ensure that underneath, it will go to one of these pods that are available based on the label selection. This makes it possible that I can say, I don't feel so well, shoot it through the head, I get a new instance with the label, it gets picked up and the traffic gets routed there, and other traffic just gets routed to the other pods that are there. Giving me the flexibility of switching between instances, so you can imagine that I could create something with V1, V2, V3, and in that particular way create different services that have different versions of my application. Now the one thing that you also can do is can say, okay, this service needs to be exposed to the outer world, and this is where we then go to the interweb. And that's where we say the service type is load balancer, meaning that it will communicate with the outside load balancer of the cluster, and it will then give you the public IP address to go to. And then you can put on top of that DNS with a name, and you get the name resolved, and you are in your cluster. Make sense? Okay, so that was Kubernetes 101. Now, these services are the things that we are going to use inside our cluster. Because my front-end application might need some APIs that we have. So what I will do is I will give my front-end, give me a replica set of, let's say, 10. I get 10 of these instances across my different nodes in my cluster. I have the same for my pods, give me 4 of those in terms of my API. Put a service on front of that, and then it can call into that service so that my front-end pods know where I can find my API. And of course, on the top side, you can then access that through my public IP address. This is the way we arrange the traffic within the cluster. Now you might say, okay, but then I get all these different IP addresses, and IP addresses are expensive, and for that we have the notion of an ingress controller where we can say, okay, we have one endpoint where things come in, and we can then create a routing table which will go to a different service. Okay, so we can say service frontend, service backend, and it still comes in on the one and only endpoint that we provide as an ingress controller. Now what is important is these ingress controllers are replaceable with different types. So you have all kinds of different flavors of these things. Nginx is more or less the default that you get. I more prefer Trafic because it adheres better to my liveliness and readiness probes. So I've seen instances where Nginx is all of a sudden routing traffic to my pods while I don't want it because they're not available yet. Well, Trafic is doing a better job in that respect. But you can use Kong Ambassador. One of the things that I used lately was Caddy, which then takes care of the SSL termination on the front side without me taking any work on that. Now, important are the health checks. And we need to have the health checks to define if we are ready to receive traffic or if we are still alive. Now, for this, it's important to know what the implications are. So, readiness means that I get a new instance, and am I ready to accept new traffic? Liveliness is more about, okay, I am there, I'm just doing my work, but am I responsive to what I do? The implication is that if I say I am not healthy anymore, that your pod will get recycled. Now, I've seen people in production say, my liveliness probe will go to my database. Oh, my database is not available. I say I'm unhealthy, and what will happen? You will get recycled, but your database is still unavailable. Does not help, okay? So be sure that you test for the stuff that you need to be testing for to get recycled, because this is more or less your signal, recycle me. Now, if you're using .NET Core, and as part of the .NET Core framework, we have these NuGet packages, ASP.NET Core Diagnostics Health Checks. We can just add those packages, add one statement in our startup code, add health checks, and give it a routing endpoint, and I get all the health information that I need, and I can create custom health endpoint implementations if I want, that then go and do stuff that is interesting for my application to define if I'm healthy or not, or if I am ready or not. Now, if it then comes to a zero downtime deployment in a Kubernetes cluster, what is going to happen? Well, we have this service, and this service then routes traffic to 3 of my pods. And these pods, you can see based on their temperature, they're green, so they're healthy, they're all happy, and they're receiving traffic. And now I go and say, okay, I would like to start version 2 of my application. So what I will do is I will say, well, in my specification, I have a replica set that needs 3 pods, so hence the 3 items here. And I'm going to specify I want to do a rolling update. Now, rolling update means I'm going to replace them while the traffic is still going on in my application. And I'm going to say that I want to have a max surge of 2, meaning I can have 2 more than the 3 that I already specified. And I can say that I want max unavailable. In this particular case, I do not want any unavailability of my 3 replicas. So only add and then remove the moment I route new traffic, okay? Now, how does that look? So replicas 3, rolling update, and the search of 2, and max unavailable of 0. What will happen is the following. So, first of all, the cluster will say, okay, I need to update. I cannot take any of the current pods out of the cluster. So first, what it will do is it will create pod with v2, and it will create another one. And these are still unhealthy because they are now probed. Are you ready? Are you ready? Are you ready? I'm not ready yet, so nothing will happen, and this will just still work. Now, the next thing that will happen is one of these will become available. So V2 becomes available. That means now it's ready to accept traffic. And what happens in this moment is that all of a sudden it starts to route traffic to V2. This implies that I have multiple versions of my application up and running, and you need to be able to deal with that, okay? No cookie stuff going on here. This is just traffic going in, and it can just be rerouted anywhere you want for the next call, Okay, so if you want to have some stickiness there, you need to take care of that yourself. Now it knows that it has 4 available. It can only do 2 search, so maximum of 5, so it first needs to kill 1. So it kills 1, and we will get a new one, v2. Needs to become healthy. The moment it becomes healthy, and then this one becomes healthy, it starts routing the traffic, it can remove another one, and finally number 3 becomes available. I can route the traffic, and my last pod is killed as well. So this is the way zero downtime deployment takes place within the Kubernetes cluster. And this is part of the default infrastructure when you just do, give me an AKS cluster. It's there for you, it will work simply like this. The thing is, your application needs to be able to take care of that, okay? It needs to understand that this can happen. Okay. Now, if it comes to observability, I already discussed that we need this information on am I healthy and how am I doing? And for this, there are different ways of looking at what observability means. So we need to know things like logging. Logging is what is going on in my application, is often used for troubleshooting and figuring out what is going on and analyzing unexpected behavior. Then we have the notion of tracing, and tracing has all to do with the fact that I have all these pods going on in my application, all these different microservices often called that I want to work with. But then I need to have full end-to-end traceability of, I get a request in, where did the request go, which pods did it hit, which application parts did it hit, and you want to be able to follow that tree along. Now, the W3C has this notion of a trace context specification, and this is being used a lot at the moment to stitch all these calls together by floating headers across these calls so that it can then be correlated. Okay, this is what we have in terms of observability. Then we have the notion of metrics, which is completely different. Metrics is more about real-time system indicators. How healthy am I? What are my call times? How fast do I respond? How much memory am I using? How much CPU am I using? And all these other things. Okay, so those are what we call metrics. It's a constant amount of data. It's always the same set of data, but we're constantly getting more or less telemetry data out of that. And then you can do monitoring based on all these things, right? So you can then say, okay, use Prometheus, use Grafana, use application insights within Azure, for example, to get that data. Now, what's interesting at the moment, you see that if it comes to these metrics, you see open telemetry now picking up in the market from the CNCF, which is then the open specification on how we should do metrics tracing and all these other things if it comes to getting this data. So how can we add this to our application? If you want something that is completely independent of any stack, you can use, for example, Dapper.io. Dapper.io is also by CNCF adding these sidecars to your pods, and it will then take care of the traffic routing. It will then add the observability. It will add tracing and metrics and all this other information to your application. And we can use a service mesh, which more or less does the same trick, but this is then for the complete, I would say, cluster, while Dapper is more focused on your application. Now, .NET Core Tracing has this notion of an activity class where you can trace the data through your application by using this activity class. If you want to publish that information, that data, you need to specify that in your startup. I already talked about open telemetry and application insights as a way to observe your application. Now, let me show you a little thing that I have here, and that is, let me go here. Global ticket, and I have my application over here. And what I have here is the solution with the front-end application. And what I've done here is in my startup of my application, I have defined that I would like to have these health endpoints. So you see, map the health check endpoints for readiness. And here I defined over here that I want health checks. For example, a slow dependency demo that I have, which is then a slow dependency health check. You can build them yourself. So I got a slow dependency health check over here that does nothing more than I will invoke it a couple of times and then I will say I'm healthy. Okay, so it just waits on those probes to actually give that data. And if I go back to my program over here, then you can also add what we call the default provided ones. So for example, this one you get based on the package that you get. So all of a sudden I can say, well, I will become unhealthy when I have more than 500 megabytes available, used. And then you see that I want to have the statistics also for HTTP, use HTTP client metrics. I get all the metrics information on calls that I'm doing to the outside world and get the response times and the data and all that other information. And then you see that I get these routes in here for readiness and liveliness probes in there. Now, when I start my application here, it will just run locally on my machine. And if all's well, it will just start up a couple of instances. So it starts the catalog service, the front-end service, and my ordering service. Then I have my application. You see the same ugly application. And if I go here, I can now see, okay, so I can go to my health endpoint and I can see ready. Am I ready? And if I look at this, then you see that I'm unhealthy at the moment. And you can see the details on why I am unhealthy. So slow dependency data says, well, the dependency is still initializing, so there's more like a reasoning why I'm unhealthy. The moment I refresh this a couple of times, see, over here, you see that I become healthy. And this is then the moment that I start accepting traffic. So this is the information I need to know when I can accept the traffic. Now I also have this notion of liveliness probe. And here you can see if I'm healthy or not. And you see that I am currently healthy. You see that the process allocated is available here. It's now 15 megabytes. And what I did is I said, well, why not create an endpoint which is called leak memory. So now I'm starting to eat 25 megs per second to see what's going on. And then I can see over here when I go to lively that my megabytes are going up to 86, 311. You see it's going up and up and up. And you see I'm currently still healthy, but I set it to go above 500, I become unhealthy. So now I'm unhealthy and now I'm reporting to my cluster, okay, kill me. Because that's actually what you're saying. And then it will recycle the pod for you, it will start again, and then, well, while you're not hitting this endpoint, it will be all fine and nice, and the moment it will leak memory again, it will then get killed again. So this is what we can use as the endpoints. Now the other thing that I did is I have a metrics endpoint, and this metrics endpoint now gives me all kinds of data on what's going on in my application. So you can see here, for example, that the request that I had was a 200 OK to the different endpoints that I had. And you can see also what is going on in terms of number of threads and number of handles and use memory and all these other things. And this is more like the static data that I can, or the data that I can get all the time. And I built pretty graphs out of that with Grafana and use Prometheus to accumulate that data, for example. And this can then give some insights for you. Okay, how is my application doing? And it's nothing more than just adding these statements to your .NET code, and you get this like more or less for free. By the way, everything is in a GitHub repository that's open source. If you go to freesmarcel/NDC London demo, you will see all this code and use that as you wish. Let me stop this one over here. So that is then observability. But we were just talking about Kubernetes all the time. So wouldn't it be nice if we would just do a deployment now to my Kubernetes cluster based on this application and see what it will actually do. Now for this I need to fiddle around a little bit, because what I have here is the following. I have, let me go here. Let me see. This is not the right one, so I will get rid of this one. You see here that I have a resource group, which then contains my cluster. So you see here my demo cluster. My demo cluster is running here. It has a couple of workloads in there. It has a couple of services in there. It has this node pool over here where I have 3 nodes running at the moment with Kubernetes on a Linux OS. And I configured it as such that if I go here and I go to global ticket, you even see that I have HTTPS because I'm using the caddy ingress. So this is my application running here, okay? And my application running here is defined in Kubernetes. And if I go to Kubernetes here, you will see that if you have a dashboard, you need to log into the dashboard. With this, you can generate a token. So let me go here and generate a new token because they expire all the time. So make it a little bit more secure, right? Everybody can look at that all the time. So enter the token, sign in. And now what you see is that I have my application up and running here. I will go to my global ticket application. You see this is my application running. Front end is then calling into ordering catalog, and my SQL Server is also running in the cluster. You see everything is up and running, everything is green, everybody is happy at the moment. Now if you look at the front end application, you've seen that it's now nicely orange. So let's try to do a zero downtime deployment on this thing. So what I will do is I will go to, let's go to my CSS over here and get some favorite color in there. Let's make it green. Lawn green, I like lawn green. Save this. And then what I need to do is now build my container, push that container to the container registry, and then run a deployment on my cluster to pick up that new container and then deploy that into the cluster. Okay, so those are the steps that I need to take. Now for that, what I will do is, I just made a change here to the green one. I will go over here and then go to my local directory structure where I will do a Docker build of my Docker file. This will now create a Docker container and make it ready to be pushed to my container registry. This just takes a couple of seconds. Now what I see here is that there's a hash code that I can use that is more or less my image. And what I will do is I will push I need to tag my image first and give it the right name. So I will use this hash, give it this name, and this will demo live. That's just the tag that I'm going to use. And now what I'm going to do is I'm going to push this demo live to my registry. And this is then the name of the container that I'm using. And what I can do is then go over here, where I have in my solution items, I have my front-end definition. You see here that I have the replicas as number of 3. You see that here is the location of my container, so that will be pulled. And you will see that I have defined that I have these health ready endpoints, where I say, well, wait 5 seconds before you try. Then try every 10 seconds if I'm ready, yes or no. So you will see that it will take a couple of seconds because after a few tries, I will return healthy. And that's then the moment it will pick it up. If it fails more than 5 times, let it be. Don't bother. Now I also have here the lively probe where I say, well, every 10 seconds, see if I'm still alive. And if I do the health trick, then you will see that it will kill my pod and it will then remove it from the cluster again. So I'm going to save this, so now it knows to pick up my new container. So what I will do is I will go over here, and what I will do is I will do so-called kubectl apply-f of my frontend.yaml, the file that I just showed you. This will apply that to the cluster, and then what I will do is I will do an get pods minus W, and you see already that it now created 2 new ones that are not ready yet because the ready status is 0. And if I go to my dashboard, you will see that it already starts indicating some issues there. But in the meanwhile, and I can go to my Selenium environment here, run the application here, and you can see that my application is still up and running here. Yeah, and this is just going very nicely. I can see my application just still up and running. And then finally it will pick up the new the items there. If I go to the details here, you will then see that it is scaling up the replica sets. So over here, new replica set. You can then see that if I go to, for example, one of these pods, let me see, 15 seconds ago, this one, you can see here that it failed a couple of times on the probe. That's the reason it was not sending traffic there yet. And now in the meanwhile, you will see that if all's well, it will then eventually pick up my, my application. Let me see where. Intriguing. My Selenium test just got killed, not sure why. If I go to the deployments here, front end, workload, it now states that it is happy and plunking away, and it is green. Okay, so it actually, my Selenium test for some reason failed, I'm not sure why. And this was the way you then all of a sudden do this, rolling update of your application. Now, let me get back to the slides. Because we've now seen how to make this happen, but there are a couple of things that we can improve on this strategy. And we have seen this strategy more or less. We have an application running, we install the new one, which is then the same as deploying a new pod in my cluster, moving the traffic there, stop the traffic, uninstall, and then do the same again, right? This is what we've been doing now in Kubernetes and in my web app definition. Now, what I would like to do is take it one step further and say, well, instead of this, install version 2, but you see it's a little bit of a strange version 2 that I have. And this strange version 2 has a reason, because what I would like to do is I would like to move the traffic there, but have exactly the same results as I have with my initial application. So what will happen is it will route traffic internally in my application to the exact same code that I had in version 1. And what I will do is then say, well, let's monitor the behavior of my application. Did anything change? And if all's well, application code 1 and 2 are the same, so nothing should have changed. So now I know that I had a stable rollout of my application. And what I will do is then release the new feature. And this is actually diverting the release, because what we're now going to say is I'm going to toggle the traffic inside of my application to a different code base that I have. And this is a way that we can internally separate release from deployment, where we say, well, let's have the notion of a feature toggle, toggling between different variations that I have of my application. And then what will happen is we will monitor version 2 behavior, and we can also monitor business criteria that I have. I can also add metrics, for example, number of items sold, number of items in my shopping basket, and all these other things to validate if my hypothesis is okay. And based on that, then say, okay, stop the traffic there. I'm confident of this version. And then what I will do is install a new version of this one where the traffic is there, because that's then the same as what we have in production, and get rid of the feature toggle. It's really important, get rid of it, because otherwise it's technical debt. So feature toggles are an important mechanism to improve the speed of delivery. And what I try to do when I work with companies is that I will move to a new mantra, and that's what we will do is we are going to have a mantra of releasing at least 30 times a day. And they go, 30 times? Why? We do not need 30 times. But the thing is, I need you to be programmed in your brain that it needs to be done 30 times a day, because then there is no time to do a change advisory board. There's no time to do a PowerPoint presentation. There's no time to get approval from 6 layers in the company to actually release something to production. So it's that mantra that you need to make the change from an organizational perspective to make this happen. And these are the techniques that you can use, because now I can deploy anytime I want. Business is never interrupted because it's still the same software going to production in their perspective. But the only thing I do is now have feature toggles where I can turn things off for specific users that I have, being it in my company, being it the special group, interest group that I have in my user base. And that's the way you then actually move to production multiple times a day. And then you can say, rollback is for chickens. That's the idea. So if you look at feature toggles versus branches, because often we're currently using branches to make differences between features that you have is that branches, they need to then live beside each other, and you have different code that goes to production than it actually is your main line all the time. And what you would like to do is always release from main, and then move everything in there, but when it's not finished yet, you guard it with a feature toggle. That way you can always move to main and always deliver to production, even if the feature is not finished. Now there are some pros and cons to this. So the pros are that you can release like any time of the day, really nicely separated release and deployment from each other, because the release is then the feature toggle, not even the traffic. And you can do multi-level feature toggles, and that gives us the ability to do a different deployment strategy, and I will come to that in my final remarks. Now the con is here that you need to manage all these toggles, and it can sometimes be what we call a pain in the neck if it comes to removing them and not forgetting to remove them, because that's really important. Otherwise, you are going to make a mess out of things. Now, you have all kinds of toggles that you can use, and Sir Fowler has written a nice post on this, the type of feature toggles that you can have. What I'm talking about is the notion of release toggles, something that we only use to release our software and divert that from the deployment that we're doing and moving the traffic. Okay? Now, you always have these things like permission toggles. That's just your authorization model that you have in your application. And if you want to do feature toggles, the only thing you need to know is an if statement, because that's actually what a feature toggle is, right? It's just how do I toggle the if statement, which is then the complexity, where we also need to know the dependencies between front end, back end, middleware, buses, etc., etc. Now, if you look at deployment strategies, if we have all these technologies that I just showed you, we can do things like A/B testing. And A/B testing is I have multiple versions in production, and I can then, based on my telemetry, see how well is my application doing, and this application version is doing better than that application version is doing, based on the telemetry, based on the traffic that I'm moving and shifting in different ways. You then need to have these analytics and get all this data out of your application to actually make decisions on what makes sense or what does not make sense. One of the things that's really important here is that you need to select your cohorts very well. And a cohort is a group of users that you define that need to see the new feature first. And that is based on your hypothesis. So you have the idea, I will sell more because my background is now green. Then you need to define how much do I think. You need to measure that, and based on that decide we will keep it or we will move on to something else. Now, the other thing that you can do is the notion of a canary release. And a canary release is where we say, okay, release something to production, and only the specific group of users is going to use this particular feature, and we're going to validate that things are not breaking. And the whole notion of the canary comes from the previous coal mines, where people went in with a canary, and the canary has a special trait, in difference from a human being, that it will die like in a few seconds when it gets toxic fumes, and a human being has then like 2 minutes to run away. And the idea is when the canary dies, you need to roll back or roll forward if you're fast enough with a new functionality. You do this by using the whole notion of traffic routing with percentages and feature toggles based on cohorts to make the specific group of users that you want to target. If you're using web apps, just use the question mark name of the deployment slot, and it will route the traffic to that particular instance. Now, there's also the notion of a dark lounge, and this is more like the canary in jail. The idea here is that we have the feature to production, but nobody can actually see that the feature is alive. This has been invented by Facebook, where they had, for example, Facebook Chat. They brought that into the system. They tested and to see what it will do with their infrastructure. How much load will it create? How much memory pressure do I get? And it will just flow the data through there, but not actual data. The data is just derived from the user interaction that you have on your normal system. But you're pushing the data through there, evaluating what it's doing based on your telemetry and information. And then finally, you can still decide to, well, take the blanks off and then make it a canary, or actually move to production as a full-fledged version of things. Yeah, so you could also say that it's a decapitated canary. One thing I want to emphasize is that you really need to be aware of not testing only for errors when you move to production. I've seen it go wrong many, many times, that people think, oh, there are no errors, so we can move forward. If you look at these graphs, for example, then you see this is my happy system. And then this is after deployment. You see 0 errors. 0 errors. This system is in panic because my CPU is spiking, my calls are all of a sudden dropping here, and I see that the times are going up to 10 to 5 seconds for a call. So be aware that memory consumption, latency, request times, and all these things need to be monitored, and not only the absence of failure. Then to conclude this session, database schema changes. How do we deal with them? So it's important that if you make a database schema change, you need to follow a certain playbook. The playbook is rather straightforward, but takes some tinkering to get right, okay? You first need to create binaries that understand schema version 1 and schema version 2. And you deploy them to production, and they can deal with the fact that we have either one of the two schemas. Then what you will do is you will deploy that to production, and then we will update the database to the new schema. Because now my application can deal with the new schema. And then what I need to do is then migrate the data to the new schema in a slow and graceful way. Because often I've seen that people all of a sudden say, okay, let's hammer the database. Just do an update of all my gazillion records, and you have like a denial service attack on your own database, which is not handy. Be careful with updating your tables. Because when you update these tables, you need to be aware of the fact that if you make a change, for example, an update column, and you do it in the wrong place, you will take a table lock and nobody can get to the data anymore. And it might take like minutes to complete. Eventually, we will then update the binaries to use only the new schema, and then you remove the old schema. So this is the playbook that you always go through. Now, some tips that I have for you when you do this. If you add columns to a table, regardless of what your DBA wants, regardless of your own OCD patterns, always do it as the last column. Do not insert it somewhere in the middle of your table, because all of a sudden all your tables need to be split and all the data needs to be rearranged on your disk. Not a handy thing to do. Always add it to the end. Make it a nullable column, because that is, for example, for a SQL server, a 0 operation. Nothing happens, you just have all of a sudden the column which is nullable. Then you can gradually update the column to have values in there, and do that with some nice queries that not hammer your database all of a sudden. And that way you have a nice way to do update. And we've done this for databases where we had like 1 billion records in there. Added columns to it, was a 0 operation. No incidents happened because of that, and we added columns to it just by appending nullable columns, which is a 0 operation. And then a good data migration strategy is crucial. And ensure that you make a difference between, for example, your hot path and your cold path. Cold path meaning users that are not active, but your active engaged users can be, for example, updated while you're working with them. Well, in the meanwhile, you're running slowly some jobs behind the scenes that then will migrate the data for you gradually. Okay? So, separate, release from deployment is crucial. You need different technologies like feature toggles, telemetry. You need web applications, traffic management, AKS, those kind of tools to make this happen. Make sure you have the whole notion of observability in place, get the metrics and understand what your system is doing. Then you have different ways of actually deploying your application to production. Now, if you want to see a real database schema change in action, I also am a Pluralsight author, and my course on deploying ASP.NET Core 3 microservices to Kubernetes, the last chapter is like an hour on how to make a schema change actually happen in a production environment. Okay, so you might want to take some time there, but I could spend like a whole session on making that happen. I hope you enjoyed this session. I will see you later with the green, yellows, and reds. I hope you enjoyed it. Thank you so much, and have a nice further of the conference.